Okay, welcome everybody. This is lesson S2, specifically on describing structures. Now, there's 5 things when we're planning that we have to consider. And so they're function, aesthetics, safety, materials, and joints. The first and definitely the most important is the function. Most people, when they're planning something, this comes intuitively. They kind of know what it's supposed to do, but it's always important to consider the function before things like how it looks or what it's going to be made of everything else. You need to know what it is the thing is going to do. Now, some examples here are going to include things such as supporting its weight. So, supporting its weight. Right? Or the weight of an object. Right? It could be containing something. It could be transporting something. It could be shelter. It could be lifting something. It could hold something in place or fastening something. Hold something in place. It could be, in fact, separating or breaking. Lots of structures are actually designed to separate or break. And so these are some examples of what things are supposed to do. Always the primary consideration. Right? And again, this is usually intuitive, but if you had a house builder whose primary function was all sorts of other things and doesn't actually consider the fact that I'm supposed to live in it, you might be wind up with a very disappointing house. The next one here is aesthetics, which is really just the study of beauty in nature. Right? Now, the best designs usually look good or are aesthetically pleasing, as it would be said. You want it to look good. People will pay a lot more for things that look good. Early impressions are a big deal. Now, this can usually be accomplished by things such as shape, texture, color, or type of materials. Or symmetry, which is that it's even on both sides, or a simplicity in the repeated pattern used in the design. Early impressions, if it doesn't look good, people aren't going to buy it. They're going to go away from it. So we want to design things that are aesthetically pleasing. It influences how much pleasure we feel, how it looks in our house, how long we want to use, even our long-term attitude towards having the item. Aesthetic design matters not only to make the first impression, but strengthens the bond with the user, and the more likely it is to be satisfied with the product overall, and taking a look at whether you buy the product even again. A lot of it depends on how it looks. This is important. Third one is safety. And now with that, a key thing is you want to be balancing safety with the cost. So, margin of safety is margin of safety to be built beyond what is required. Whether this be being able to handle larger loads than what it would normally be able to take or whatnot, margin of safety is kind of like a buffer zone. for keeping people safe. Now, the Death Star really took its name literally. Thinking of Star Wars, just taking a look at a few things in terms of safety. Here, first of all, in our first picture here, this is right next to a super death laser. Some text here, and notice here, this has very little room for them to stand on and no guardrail. Right, so they're standing here right next to super death laser, no guardrail, nothing to hold them back or to make sure that they don't step off this itty bitty tiny platform where you've got two people working side by side, two operators. Right? This is not safe. Right? This leads to Death Star taking its name. Look at this situation here. Here we've got Obi-Wan Kenobi. He is messing with controls. Now, again, the controls, he's got like, my guess would be about 7 inches here in order to operate this computer. Okay, no guardrails again. Okay, this is not a good place for a person to be operating. Right? I want to talk a little bit about materials. Okay, first of all, composite materials. These are materials which support systems surrounded by other support systems. So if one fails, the other can hold. Composites materials are made up of more than one material. And they also have different properties. Now, some examples include fiberglass and plastic working together, or concrete and metal, such as the rebar in a driveway, where it's designed to work together. And so these things are usually form what we would consider one item, one material, but they're actually made up of multiple things. Now we can also layer the material, and if we layer different materials together and press and glue them together, we get produce a useful combination of properties. Properties are just characteristics that match the purpose of the structure. Plywood would be an example of this, where within plywood you actually have multiple layers of wood that are glued together, usually in multiple directions. We can see materials that are woven or knitted together. This is to allow things to be very flexible. Because they're able to stretch in all directions. These materials are very useful for lightweight structures. Such as tents and clothing. Now, when choosing material, there are lots of things that you are going to be taking a look at, right? Deciding what you're actually going to build with. Cost is usually a big one, right? Because things that cost less are going to be more desirable than things that cost more. However, it also could mean poor quality, right? So we'll want to make sure we, again, balance that cost with the quality, but we'll want to do it as cheaply as possible and usually with as high quality as possible. The appearance or the aesthetics. Now, the appearance may or may not be useful, especially if it is something that is hidden. You don't really worry about the appearance so much. If it is something on the outside, something that's going to be seen, you're going to want to make sure that it's used for a long time. A third one is the environmental impact. Okay, if we use recycled materials to save the earth, or something that's going to be less damaging. Another one, in some cases, is going to be the energy efficiency. Now, this depends on what you're looking at, may or may not be a factor, which is why we list it fourth. But choosing specific materials may help to keep heat inside. A structure. I forgot the word keep. That's the third blank. Keep heat inside a structure and lower the energy costs needed in a structure. Okay, so that energy efficiency is something that we actually talked about in the last unit. A little bit more on joints. Joints, how things are actually fastened together, is going to be our last area of consideration, right? Right, so we know what it's made of, the margins of safety. How we're actually putting the different pieces together, fastening together, is kind of the last thing that we're going to consider. Now, joints that allow movement are called mobile joints, and joints that prevent movement are called rigid joints. Right, so an example of a mobile joint might be something like a doorway, where an example of a rigid joint might be between the back of chair and chair bottom. Now, depending on your chair, you may actually have that as a mobile one, right, where people can lean back. But a lot of times they're also rigid. And this is something with the designer. So, rigid joints fall into 5 categories. The first one is a fastener. Items such as nails, staples, screws, right? Thing that with fasteners, though, the more you use, the weaker you're actually going to make the material, because they actually dig in and remove some of the material. Another one is interlocking shapes. Okay, can be used to strengthen structures, kind of like pieces of a puzzle. They are carefully shaped parts. That can hold themselves together like a dovetail joint. If you've ever built some sort of build your own furniture, a lot of times you'll see where you've got 2 pieces, maybe a board up here with another piece here, and they actually have holes in both sides, and you have kind of like this piece of wooden doweling that comes together, and you lock them in place. That would be an example of an interlocking shape, right? You're not using a fastener like a nail, but you're just using interlocking shapes to keep them together. And usually building your own furniture has both fasteners and interlocking shapes. We can also use ties, such as thread, string, or rope, to put things together. Another one is an adhesive, which is a glue or sticky substance, right? So that could include things such as tape and whatnot. And lastly, we could actually even melt the joints together, melting the pieces together. These will make for a much stronger structure, a more permanent structure, but typically it's also a little bit more difficult and requires a little bit more skill. So let's take a look at a few examples just to wrap things up. Containing, sheltering, transporting, lifting, describe what? That's right, it will be the function. Taking a look at number 2, when a structure is built to withstand loads more than it would normally carry, the structure is built with a large A, B, C, or D. That's right, D, margin of safety. Number 3, which of the following criteria is a good design that is usually not written down in specifications, but is one that the customers notice first? A, B, C, or D? That's right, aesthetically pleasing. The thing here is that they notice first. They're going to notice how it looks first. Number 5, which of the following is an example of a composite material? A, B, C, or D? Answer C, fiberglass, which is made up of many different types of materials. Okay, architects, engineers, and designers usually do not consider all of the following when choosing material to use. Which one do they not usually take when looking at the material? A, B, C, or D? And that's right. Answer B, symmetry. This would be one of the design features, not of the material, but how we're putting the materials together. Mobile and rigid joints are used to secure material together, which is the following example of a rigid joint. That's right, the standard Lego bricks. Those are the ones that have the pieces that completely lock together, right? Usually with, let's say, 4x2, right? And it locks onto another piece. Right, where you see them overlap. A type of adhesive that hardens as it cools is an A, B, C, or D. And that would be an A, thermal setting glue. Okay, so homework for this section 296, 1 to 4, and then a topic 1 and 2 review can be found on page 297. Thanks for watching. Have a good day.